Welcome to the Chapter 6.4 Part B lesson video. Today we're going to talk about something called complex fractions. So complex fractions is a bit of a scary sounding topic, but it's really not that bad. There is a simple rule that you can follow, and if you can follow that rule, then you can do these different types of problems. And there's really kind of two main types of problems, and we'll go over that here shortly. All right, so we're going to be able, so this is a part of the section that we did before, 6.4a, where we're adding and subtracting rational expressions, and this really deals with a sort of special type of situation. All right, so a complex fraction. So by definition, a complex fraction is a fraction where there are fractions in both the numerator and or the denominator. So what that means, it's a fraction of fractions. You see how there's little mini fractions, little sub-fractions within the big fraction. Okay, so that's what a complex fraction is. It's a fraction, a super fraction. Okay, so we can always simplify these complex fractions by multiplying the top and bottom, every term in the top and bottom, by the least common denominators of our subfractions. All right, so that's a really fancy way of saying we can simplify this thing by multiplying every term, every piece, every little sub-piece, whether it's a fraction or not, by the least common denominator of our little sub-fractions here. So what that'll look like for us is the least common denominator of our sub-fractions is 2y. So I'm going to multiply every piece here by 2y. I'm going to multiply this by 2y. I'm going to multiply this by 2y. I'm going to multiply this by 2y. I'm multiplying every part by 2y. I'll reduce anything I can. So in this top left one, the y's reduce. The 2's reduce, and this one, the y's reduce. And then I'll multiply out what we have here. Okay, so I now have 2 times 1 on the top left, which is just 2, plus 1 times y, which is just y, over 5 times 2, which is just 10. And there we go. We no longer have what we would call a complex fraction. This is now simplified itself, and we are done with this example here. Okay, so that's complex fractions in the short. It's if we have a fraction of fractions, then we can use this method to kind of quickly simplify them down. Okay, let's go ahead. We're going to try a couple examples here, and I'll talk about them pretty quickly. The first one's pretty straightforward. The second one's a little trickier, but let's go ahead and look at them. So the first one, the least common denominator of all these sub-fractions, right? There's a complex fraction of fractions, is 2x. So everything gets multiplied by 2x. All the pieces, not just the fraction pieces. We reduce where we can. Nothing reduces on the top left. The top right, the 2's reduce, and the bottom, the x's reduce. All right, we can just multiply out and simplify what we got left. 2x times 5 is 10x. 1 times x is just x. And then on bottom, 1 times 2 is just 2. And then if there's anything else that continues to simplify, we should absolutely do it. Yeah, on top we have like terms now. 10x plus x is 11x over 2. Perfect. There's our answer. All right, next one's a little trickier just because it's a little more complicated looking. If we look at the least common denominators here, we got to figure that out. So we got w squared, so we need at least a w squared. That'll help with this one as well. And we have a 2 and a 7. All right, so the least common denominator for 2 and 7 is going to be 14. So 14w squared. So everything gets multiplied by 14w squared. 14w squared. 14w squared. 14w squared. We're going to reduce what we can. So this will take a few seconds here. We'll get rid of the w squareds on that part. The 14w squared divided by 2 is going to become 7w squared. Here, the 14w squared divided by the w is going to leave me with just 14w. And then lastly, the 14w squared divided by the 7 is going to leave me with 2w squared. All right, we're going to multiply what's left over with the numerator. So 14 times 1 in the top left is 14, plus 1 times 7w squared is 7w squared, over 14w times 1 is 14w, and then minus 1 times 2w squared is 2w squared. All right, now you might want to rewrite this in standard form so it's a little nicer looking. 7w squared plus 14 over negative 2w squared plus 14w. We could try and simplify a little bit, like on top we could pull out a 7, on bottom we could pull out a 2, but that doesn't really help us at all. So there's really no point in doing that. If you did it, it wouldn't be wrong, but this is your best final answer. Okay, now there's actually one other way we can use this complex fraction situation. Now, this problem is not currently a complex fraction. It has fractions, but it is not a fraction of fractions. But we can use a little tricky math trick to help us out here. We can put anything over 1 and it keeps it the same, right? X over 1 is still x. 5 over 1 is still 5. We can put this whole thing over 1 and it's still the same expression. Now we have fractions in a fraction. We have a complex fraction, and that only happened because we put it over 1. Now the complex fraction rule says if I multiply everything here by the least common denominator, I can keep doing that same thing that I did before. So least common denominator here, I have a 7, I have an a and a b. Those are all my denominators, so 7ab. All right, so we go 7ab, 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 7ab. Now a really common thing, people forget to multiply the bottom. 7ab. Everything, all the pieces separated by addition and subtraction get multiplied by 7ab, and then we can reduce what we can. So on this first term, the a's go away, second term, nothing, third term, 7's go away, fourth term, the b's go away, and then on bottom, nothing goes away. And now we just get to multiply it all out and see what is left over. 1 times 7b is 7b. 5 times 7ab is going to become 35ab. 2 times ab is plus 2ab, and then 10 times 7a is going to be 70a. All of that is over. 1 times 7ab is 7a. B. Now there is one more thing we can do here. We should always look and double check, are there any like terms? And yep, there is. There's 35ab and 2ab, so we can go ahead and we can combine those together. So this is going to become 7b plus 37ab plus 70a over 7ab. If there's any other simplifying, we should do it, but there isn't. So we can go ahead and leave this as our final answer. Okay, one more practice, same idea. This is not a complex fraction at the moment, but if I take the whole thing and I put it over 1, it is now a complex fraction because we got those little sub-fractions up here up top. Least common denominator, if we look through, least common denominator here is going to be x squared. So everything gets multiplied by x squared. X squared, even the bottom, most common mistake, people forget to multiply the bottom. Everything gets multiplied by that x squared. All right, so we'll go ahead and reduce what we can. So the x squared and the x leaves us with just x. The x squareds reduce, nothing else reduces. So when we multiply this out, we have 5 times x squared is 5x squared. Plus 1 times x is plus x. Minus 1 times, there's nothing else there, so it's just the minus 1. And then 1 times x squared on bottom is just x squared. And this is our final answer. All right, with that, you should have enough information to be able to get started on the assignment. If you have any questions, please reach out. Otherwise, I'll see you guys in our next live session. And until then, I hope you have a great day.